In this problem, I'll talk about a spinning bicycle wheel. So we have a cyclist here, and she is cycling, and then the wheel, when she starts doing it, the cycling it, the wheel starts from rest, and it comes to a final angular speed of 200 rpm. The rpm stands for the revolution per minute, and the time it takes is 4 seconds. And now we need to calculate what is the average angular acceleration. That's the first part. And in the second part, what you have to calculate is now in the second part, she applies the brake. After she gets tired, she applies the brake, and the wheel comes to a stop in 20 seconds. Now you need to find out again the average angular acceleration and what is the angular displacement, and also you have to find out the number of revolutions, or how many turns the bicycle wheel makes it before coming to rest. So let's do it. So first part, I'm just talking here about the first part here. As the wheel is starting from the rest, its initial angular speed is 0. Omega is the angular speed, and I stands for the initial, which is 0 radian per second. And it does have an angular speed of 200 revolution per minute in 4 seconds. So the final angular speed, again F stands for final, is 200 revolution per minute. You need to change revolution per minute in radian per second. Always remember to change the angular speed to radian per second. How do you change it? So it's given here, rpm, revolution per minute, to radian. The one revolution, that's the first, the revolution per minute. One revolution, what does the one revolution means? This means one complete cycle, which has an angle of 2 pi or 360. So 2 pi radian. One revolution again means 2 pi radian, and the 1 minute is 60 seconds. So 260, you'll get 30 here. So one revolution per minute is pi over 30 radian per second. This is 30. Okay, so now it's easy to change it. So simply you have to multiply by pi over 30. So 200, now pi over 30, that takes you to radian per second. So after calculating, what I got is my final angular speed is 20.9 radian per second. And the time is also given, is 4 seconds. That's the final time. And your starting time is always 0. Or if it is given other time, that you can choose that time. So this is 4 seconds, or the change in time basically is 4 seconds. So we'll calculate the average angular acceleration. As it says, the angular acceleration or average angular acceleration, what does that mean? Is what is the change in a speed divided by the change in the time. Okay, so you need to find out the change in the angular speed. So this is the change in the angular speed, and this is the time, or the change in time, or the time interval. So the change means the final angular speed minus initial angular speed, and the final time minus the initial time. And the final angular speed is 20.9. And as the wheel is starting from rest, its initial angular speed is 0. And again, the final time is 4 seconds, and you are starting your time from 0. So this is 0. What you get is 5.22 radian per second square. And this is a positive value. What does the positive value of angular acceleration means? The positive value of angular acceleration means that the speed increases. The wheel is turning faster and faster. That's what the positive value of angular acceleration means. So if you need to understand a little more about it, the average angular acceleration, you need to you already have studied about the average linear acceleration, and it's exactly the same thing. This is in linear motion, so average angular acceleration is the change in velocity divided by the change in time. This is exactly what it is here. So you just need to translate the linear motion to rotational motion. That's it. And one thing, I'll just make a slightly change. As it is saying the average, I'll just put one bar here. That means this is the average. So this line always means the average. Okay. And the second thing we need to calculate is now, okay, so now C applies the brake, and then we need to again calculate the average angular acceleration. So before applying the brake, the wheel was turning. The wheel was turning and the angular speed at the time was 20.9. That's for the part 1. Now for this part, when she applies the brake, this becomes the initial angular speed, 20.9. And she has applied a brake, and after a certain time it comes to rest, or it comes to stop. So the final angular speed will be 0, and this will be initial angular speed. Okay, for the second part when she applies the brake. So you just see the notation now for the when she was speeding up, when she started cycling, so her initial angular speed was 0. Now she applied the brake, her final angular speed is 0. But now her initial angular speed is the final angular speed of the when she was cycling, or she started cycling, or she started speeding up. So the final time is 20 seconds, because it says it took 20 seconds. And now the change, again the same formula here, the average angular acceleration. The average angular acceleration is now the change in angular speed divided by the change in time, which is the final angular speed minus initial angular speed. What is the final angular speed? Which is 0 radian per second. And the initial angular speed, or omega naught, sometimes we also denote it by omega I, is exactly the same thing. But just to make consistency, or I'm just calling this as omega I, it's exactly the same thing. So some books just prefers to write omega 0, sometimes even I write omega 0, omega I, so it's exactly the same thing. Omega f, which is the final angular speed, is 0 because it finally came to a stop, and this is your initial 20.9, and the change in time is 20 seconds. Now if you solve it, what you get is negative 1.05. What does the negative sign means? The negative sign means the angular speed is decreasing. That means the wheel, or the bicycle wheel, is coming to a stop. That's what the negative sign means. If it is positive, what does that mean? That means it is speeding up. The negative sign means it is slowing down. And now we need to find out what is the angular displacement, or how many turns the wheel has turned before coming to a stop. So let's calculate it. So again, all the formula here, if you know all the formula in linear dynamics and in linear motion, you can simply translate into the rotational motion. So again, the angular displacement, you need to familiarize yourself with all the notations. So the angular displacement here is simply equal to theta. Okay, we know this equation, v square is equal to u square plus 2as, and this is in linear motion, and I'm going to translate this equation into rotational motion. So v is the angular velocity, so in terms of the rotational motion it will be angular speed, omega f, and u is the initial velocity, so it will be initial angular speed, plus 2, a is the angular, A is the linear acceleration, and in linear motion it will be angular acceleration, and S is the distance, the linear distance, and in rotational motion it will be the angular distance, or what we call the angular displacement. That's as simple as it is. So the final angular speed is 0 because the wheel has finally come to a stop. And the initial angular speed is 20.9. That's already we have calculated this one. 20.9 plus 2 alpha, which is the angular acceleration we just calculated, is 1.05, and theta we need to calculate. If I solve for theta is 208 radian. So sometimes we are not very used to with the radians, so let's calculate the number of revolutions. So one revolution is equal to 2 pi radian. That means if it makes one complete rotation, the wheel, one complete revolution, the total angle is 2 pi. So the 2 pi radian. So 1 radian is 1 over 2 pi revolution. As this is given in radian, we need to change the radian into revolution. That means we simply need to divide it by 2 pi. So 208 radian and dividing by 2 pi, that gives me a revolution. So the wheel has made a complete turn of 33 complete turn before coming to a stop. So this is how you calculate the average angular acceleration and the angular displacement, the number of revolutions made for a spinning bicycle wheel. Again, if you have any questions, write down your questions in the comment section below, and do not forget to like, share and subscribe the channel. Thank you very much.